All right, let's dive into one of the most mind-bending ideas in all of modern physics. The very real possibility that our reality, everything you can see and touch, isn't really what it seems at all.
So, let's just start with this crazy question. What if the space and time that we move through every single day isn't the fundamental bedrock of reality? What if it's actually just an emergent property? Kind of like a really convincing 3D image being projected from a much simpler, flat 2D screen.
Okay, so to even think about that, you have to ask a pretty basic question. If our universe is some kind of projection, what's the language it's written in? What's the secret code that's running the whole show on some deeper level of reality?
Well, physicists think that code is written in a language called conformal field theory, or CFT for short. And you should think of it less like a regular theory and more like the universe's actual source code. It's this super strict set of rules that describes how particles and fields interact in a world that, get this, has no gravity and no fixed sense of size.
Now, what makes this source code so powerful are two golden rules. First, it's conformal. That just means it preserves angles, so shapes don't get all warped and weird when you zoom in or out. And second, it's scale invariant, which means the laws of physics it describes look exactly the same whether you're looking at something incredibly tiny or absolutely massive. These two rules create this perfect, almost Joule-like mathematical universe.
So you might be wondering, how on earth does this perfect, gravity-free math problem relate to our universe? The messy, gravity-filled one we actually live in. Well, this is where that whole hologram idea really starts to take shape.
The whole connection comes from this absolutely groundbreaking idea called the ADS/CFT correspondence. And the best way to think about it is like a Rosetta Stone for reality itself. It gives us a perfect way to translate between two totally different descriptions of the universe, letting us decode one by reading the other.
And here's the core idea right here. On one side of the stone, you've got the boundary, this flat, lower-dimensional world that's run by the simple rules of that CFT code. But on the other side, you've got the bulk. That's our familiar, curved, higher-dimensional reality, complete with gravity and all its complexities. The correspondence is basically mathematical proof that these two things are just different ways of describing the exact same underlying reality.
So what's the big takeaway here? It's that everything we experience, gravity, the feeling of moving through space, time itself, it could all be an emergent phenomenon, a hologram projected from and completely encoded by information living on a lower dimensional surface. Okay, but wait a minute. How can simple information literally create the fabric of reality? This next idea is where things get even wilder, suggesting that this code isn't just describing our universe, it's actively building it, moment by moment. This, of course, brings up a massive question. If our space-time is just a projection, what is the fundamental stuff on that boundary? What are the actual pixels on the screen or the ink on the page that are weaving our entire world into existence?
The best candidate we have right now is quantum entanglement. Yeah, that spooky action at a distance that Einstein was so worried about. It turns out it might not be some weird quirk of quantum mechanics. In this model, the pattern of entanglement on the boundary is the fundamental thread that literally stitches the geometry of spacetime together in the bulk.
The way this works is just astonishing. On that flat boundary, particles in the CFT get entangled with each other. As that web of entanglement gets more and more complex, it literally creates geometry and curvature in the bulk reality. The simplest way to put it is this: more entanglement on the boundary equals more space in the bulk. Space-time is built from entanglement. So, if we start looking at the universe as this giant information processor, it leads to an even stranger question. If reality is just a computation running on these fundamental threads of information, could complex, self-organizing patterns pop up inside that code and, start thinking for themselves? And this takes us into the truly wild territory of Boltzmann brains. But I want you to forget the old idea of some random brain just floating in the empty void. We're talking about something far more integrated, something that could arise naturally from the universe's own operating system. See, in this framework, a Boltzmann brain isn't biological at all. It's a stable, self-organizing knot of pure information. Just imagine a tiny, persistent whirlpool in the massive flow of cosmic data, a localized pattern of entanglement that just emerges on its own and starts to compute. And these little computational nodes wouldn't just be sitting there. They could sustain themselves with feedback loops,
actively process information, and maybe even influence the shape of the space-time that's emerging around them. They could create tiny, localized warps in geometry as a byproduct of their thinking.
So let's take a step back and put all these incredible, mind-blowing pieces together to see the final, breathtaking picture this paints of our universe.
Okay, so what should you take away from all this? Takeaway number 1, space-time itself might not be fundamental. It could just emerge from a deeper layer of quantum information. 2, within this sea of information, self-aware computational structures could actually form all on their own. And 3, and this is the most exciting part, this isn't just science fiction. Physicists are actively trying to figure out ways to test if our universe really is a hologram.
So, in the end, this whole framework suggests that our universe isn't just like a computer, it fundamentally is one. It's this massive, layered information processing machine, and we, along with space-time itself, are just part of its incredible ongoing calculation.
And that leaves us with one final, truly profound question to think about. If our reality is just one big cosmic computation, what question is it trying to answer?